go live. Still loading. Looks like we're
Hello,
up.
Eric. Yeah. Hi, Eric. How are you?
I'm doing good. How are you, Tatiana?
Good, good. Hello, everyone. Let's look at our Q&A and let's see if we don't have any questions yet. So first things first, let's make sure everybody can hear us. Eric, if you can let anybody know that they can write to us in the chat.
Yeah. And I'll put what I usually do as well in the chat. I will put our tech support phone number and email address. So after the webinar today, you can contact us there and ask us any questions moving forward.
Okay, so let me write to the audience. Okay. Now, the first thing I want to do is if can you guys let us know if you can hear us. That's very important to make sure that the audio is good, that you guys can hear us correctly before we get started, and make sure that we have a good communication. Also, the idea behind this webinars, all webinars, is to answer your questions and be able to have you participate on them. So if you have anything you'd like us to go over or talk about specifically, don't hesitate to write to us through the chat. That's the point of these webinars. Okay. Hello,
Thank you,
David.
David.
How are you? Loud and clear. Perfect.
Let me try to change the template here 1 second and we'll get
Okay.
started.
Perfect. Oh, that's much better.
Awesome.
Okay. So, our idea behind this webinar today is go over specific features that we both believe are going to help you as a user when you are using our latest versions of the product. Now, the good thing is that Eric not only does webinars and demos, but most of the time he spends with you as customers doing training, you know? So I would like to start with you, then I'll give my input. Uh, Not only for B38, but in the last couple of versions, 37, 36, what functionality do you believe has helped customers the most on your training sessions? And I want us to divide this into two different scenarios:
Okay.
functionality and features that are going to save us programming time, like time working on our computers, and functionality that's just going to reduce our machining time or our tool span, or it's just going to make our tools last longer. So I want you to go over those features, and as you go over them, I'll give my input, and then I'll go over my features that I believe are very helpful.
Okay. Yeah, and I think we could give a good overview of what that looks like with saving time programming. In our newer versions, we can create templates in the CAM side of it so that we don't have to recreate the milling operations every single time. We have our new tool manager to be able to create tool libraries between different machines, different users. The new user interface in version 38 is a big one. And also, another big one in version 38 is selecting solids and surfaces for our lathe turning jobs when we don't have to create wireframe anymore. The second part of it that we'll be going over as well for saving time, machining time, we can control our feed rates much more efficiently, set tricoidal cutting for 3-axis milling and 2-axis pocketing as well. And also we can look at our premium tool paths to look at how to save time machining with more efficient toolpath.
Okay, let's get started.
So in version 38, look at that list again here. So we look at saving times programming. So in a milling job, I'll just open up one from my, let's see, our demo files, 3-axis mill demo. We can save time by, if I'm doing many of like drilling operations like this, and then going in and very frequently doing an advanced rough and maybe doing an advanced planer for this part file here, I can save all of these operations here in my milling job as a template so I don't have to recreate them every time. I can do that by right clicking on the milling job, going to about 3/4 of the way down, going to save as job template, and I can name it whatever I want here. I'm going to name it webinar template. And so when I go into a new file, I can open a part
Before you do
file.
that, let's
Go
let's
ahead.
let's show them something cool. So
Yeah.
I want you to take that same very part that you have there, okay?
Yep.
And I want you to go to home,
Home. Okay.
and I want you to save this as a component.
Okay. Yeah, that's a good one
Okay,
as well.
yeah, so let's save it as a component. That's a new functionality that we added in V38. So
Yeah.
let's do that.
Yeah. So just like saving as a job template in CAM, now we can save geometry as a template. Very similar. Under Home, we have this load component and save component. So I can click Save component. Let's
And let's
see.
call it let's call it like mold type number one, so we know that this is the one type of mold that we have to do.
Yeah. Mold type number one. Select my geometry, and then save component.
Before you do that, create a folder which we're
Yeah.
going to call it imported files. That way we know that these are not parts that we created on Bobcat, but we imported it from
Mm-hmm.
somewhere else. And then you can create a subfolder under imported files that is called molds. So
Mm-hmm.
what I want to show you guys here is that you can be very organized with your parts. You can keep track not only of the actual type of part that it is, but then a subfolder to be like, okay, this is part of the imported files, but it's also part of the mold sub section.
Yeah, right. Sort of a subfolder of
Yeah.
different types like this. So we
Hmm.
can select, so that would be mold type number one,
Hmm.
select, and then I believe it's going to be save to file, right? Or is it
No,
save component?
save to component.
Save
That's it.
component.
And just make sure that you pick go into that. It that one says, yeah.
There we go.
So you see
Mold.
you have your subgroups. So
Yep.
pick one of the subgroups and put it there, and then you can rename it after.
Molds
Mhm.
subgroup,
Mhm.
and then select it, and
And
then
then
save.
just press save on the button. No, save on
Oh,
that one
save at the
doesn't work.
very bottom.
Yeah, there.
There it is.
Hmm.
Just cut off. There we go.
Exactly. So once you do that, now let's just open a blank space,
Okay. There we go. We're in a new file.
and then we're just gonna load our component.
Then load component. Load
Uh-huh.
component
And then
into
let's look for our subfolder, imported files. There.
and then
Now,
open.
this is where it's gonna make a difference. Not only you can place it anywhere you want, you can pick different positions to place it. So just make it to the left hand side, bottom left corner, so it's easier.
Okay.
Hmm. There. And not only you can do the bottom left corner, I think that's the center, but you
Oh,
before
fine.
you put it, you
Mhm.
can make changes to the geometry. So the
Yeah.
let's we programmed that part as it is, but I want to bring this part and change the size. So we want to you before bringing the component, you can
Hmm.
actually change the scale ratio when it comes in.
So
So
here
not
and
only
scale
then
factor.
scale, and let's make it 1.1
Okay.
there. So it's slightly bigger than the other one. You bring it in, you place it on your in your 0, 0 position.
Hmm.
That's it. And then you just load the um, template, the programming template, and you're done. So
Hmm.
now there's going to be a synergy between your CAD templates and your CAN templates, and it's just going to make your programming process so much faster.
Right. Yep. So that's CAD templates, our CAM
Mhm.
templates as well, to be able to now, since we've scaled this up and we have our CAM template that we created as well in a job template, we could go right to CAM, and instead of a new job from scratch, just like in the CAD components in version 38, we can also select the webinar template. It has all of our features in here that we have saved, just like in the save and load components for CAD as well.
So at this point, all you have to do is pick your geometry and compute. That's
Right.
it. Now, before we continue, are these features clear? Do they make sense? Does this tells me how many people are watching this?
Yes. It tells you at the top left where it says live on our side.
Okay. No, it doesn't show me. Maybe because I'm not on the invitation.
Oh, gotcha.
So,
It's saying there's 5 people live currently, people filtering in and out, but
okay. Okay, so let's continue with what you prepared for us.
oh,
Just if you want to show how you just reprogram that, just pick the geometry and recompute.
yeah, sure. So in our feature 3 axis here for advanced roughing, I can just right click on geometry, reselect, select the solid model that's been scaled up, right click on the boundary, reselect, and then just select the loop here for my going around. And then right click on the feature and recompute. Compute all toolpath. It doesn't like the clearance plane. I can change
Boundary.
that
Oh, the clearance plate. Yeah.
top of feature and clearance plane.
Mhm.
So I can compute from there. Oh, it's at 1.1. 1 and 1.5. There we go. And there is our geometry, boundary, and toolpath. Wonder what the tool is here. Advanced rough, half-inch cutter, and center cutting tool. Center of tool, and compute from there. Maybe I'll turn off the boundary.
You know what it might be?
Mm.
Setting up the material, the stock.
Oh yeah, you're right. The
Yeah,
stock is
your
all the way
stock.
down
Yeah, is this not gonna work?
there. Right.
Then you have to set up your origin. Yeah, there it is. Now
Yep.
it worked.
Right. So the stock saw that there was nothing up here. So yes, when you create a new job template, you have to make sure that the stock is surrounding your new part file wherever it's located in space
Mhm.
here. But
So ideally, what this feature shows you is we normally find ourselves programming similar parts over and over again.
mhm.
So you don't have to be doing it every time for the drawing or for the programming. Once you save a template, you can always come back and use that template as many times as you require and just make small modifications. Now, something that I want to, now that we're here, let's say, can you open the feature 1 second? Just double click
Yeah,
on
the
the,
feature 3 axis.
yeah, the triads. Just double click on the feature on this. Okay.
Okay.
Now we move in the right hand side to parameters.
Parameters here, patterns
Mhm.
and parameters.
Yeah. So this is where V38 it's gonna make a difference. So I want you to get closer to the toolpath for a minute.
Okay.
There. So if you look at our step over, I can't really see because I have a reduced screen. What's our
Mhm.
step over right now?
Depth of cut and step over are 100 thousandths.
Okay, so let's make that let's double that for a
Okay.
second. Mhm.
And then when I hit tab,
Now
it'll
on the top
mhm.
there's a compute toolpath. You see it just besides the blank option.
Up here. You're
No,
saying?
no, no. On the top.
Oh, top.
Okay, so you no
I,
more to
I
the right,
yeah,
to the right, to the
I
right.
almost never,
Uh,
I almost
there.
never use these
Yeah,
icons.
click there.
Okay, compute toolpath.
Uh-huh. So this is This is the big differentiator. You don't
Mm-hmm.
have to click away, get out, and recompute. Even for three axis operations, let's say he decides to let's go into lead in and lead outs,
Lead in and lead outs right here. Okay.
and then I need you to change it to plunge. So we're gonna plunge in,
Okay.
and then just press the compute button.
Okay.
Now you want to see how it looks, so you just click on backplot.
Click on back plot. Is that up at the top that we have?
Yeah, a
Oh,
little
back
bit
plot. Yeah, there.
there, and then you can check on that very moment
Yeah.
what's gonna happen. So
Nice.
just yeah, exactly. So then I see like, okay, so that wasn't a good idea. You know, I should have a ramp in or before that, because I'm just gonna crash my tool
Mm-hmm.
without having to get out of the feature. I just go back into the operations, change my lead to ramp in, and recompute really quick there.
Yeah, it doesn't like that. Let's do spiral ramp
Uh-huh.
in.
Yeah, perfect. And then you can just backplot. And for me, this is huge
Yeah.
because you're not having to go back and forth to see all these changes. Uh, and we all know that programming is this, it's trial and error. You
Mm-hmm.
see, you check, you look at your toolpath. You're probably not sure about what's happening, then you go back and then backplot it. But now you don't have to be go to different places to do this. Everything's happening right there on the left hand side. Now it might look different, but I want you to quickly hover like one of the features. Go into the operations, back
Am I
into the
canceling out?
no, don't cancel. Go into the
Okay.
operations
Oh,
on
under machining
no,
strategy.
yeah,
Okay.
just go to operations,
Mm-hmm. My available operations here.
and then parameters. Go to parameters.
Parameters. Okay.
Mhm. Okay, so hover over the spiral option or the lead in and lead out. Just hover over that area,
Okay.
and you'll see this is very helpful. No,
You're
on
saying
the
that
actual
on the left.
uh
Okay.
hover on spiral or
Oh,
in mhm,
like if I'm here.
yeah. So I don't know if you guys can see it. Every time he's gonna hover into on a specific feature, it's gonna show the help system.
I think I have to turn on contextual help down at the
Oh,
bottom.
you have it
This
up?
icon is for here. Yep. I usually
Okay,
have them turned off because I know
okay.
what they are. But if I don't, I can turn on the contextual help down at the bottom next to snap increments, and it will show
So
me.
this is very helpful because it's not only gonna show you what it is with a picture, it's gonna give you a description, and more importantly, you can actually click on the help system, and it takes you to where that feature is on the help system. So again, we're trying to make sure that customers are able to find all the information whenever they need it. And this is a good way of just you're going through a feature, you're not very sure what that feature does for you, so you just click on help system and it takes you there.
Hmm.
Can you show us another one,
Sure.
Eric?
So we go to leads and we can hover over line, and
Hmm.
it will let me open the help system and go right to that entry and leads page here, and gives me a description of everything in terms of the lead options.
So again, that's something that our development team worked very hard because they had to go through every single feature that we had in the CAM tree for milling, lathe, wire, and link it to our specific help system section. So for new users or even people that are upgrading from prior versions, this is very helpful because a lot of people upgrade, but they still keep using the same functionality and features that they were using on B38 or V36. So they get a new version, but they're not really getting the value of their investment. This is a way to get it, because when you're looking at this tricordial option and you want to learn or understand more what that means, you can, or this high speed, you can just click on the feature and it tells you the difference between them. So there.
And even
Does it
so,
answer
as I
that?
was scrolling down, I saw the tricoidial milling and other small things that uh, are tough for me to even explain. When I do the demonstrations of the software program, like the number of intermediate steps, it shows you a description of exactly what it's doing multiple passes in here to remove as much material as possible for your finish pass without having to do it all the way across the stock. It's a great way to see exactly what these features, what these settings actually do in the software program, and helps you learn more of how to optimize the toolpath for you.
Okay, so it looks like I'm hijacking your your webinar, but I
No
think
problem.
those things are very important to look into.
Yeah,
Continue.
definitely. So yeah, we're back to our list. We did the templates, and then also tricodio milling. We looked at. Where are we going next?
Could you give me a better explanation for trichotomy? I think we have a good article. Let me see if I can find it and share it with you. Okay.
Okay, sure.
Let me
And as you're looking for
let
that
me go
article,
to our
tricodio
site.
milling,
Yeah.
we can see here. Like adaptive roughing creates a high-speed machining operation with automatic tool engagement settings. So it keeps constant tool engagement as it cuts across each depth. So instead of wasting time stepping over like the offset pocket options, it's continually machining. A lot of customers will use this for softer material so they can have a much higher depth of cut and mill out much more material at a time, a smaller step over, but a much larger depth of cut to machine much more quickly there. And that's our tricordial milling. Again, our high-speed machining option. This is a zigzag cut pattern, but if I change it to zig, you can see in this description, as it gets to the next pass here and needs to retract and link to the next step here, it's going to just retract just a fraction of an amount and rapid across to the next position. So instead of the offset in and offset out, where it's linking each step over here, stepping over the same feed rate, it's going to wrap it to the next location for our adaptive roughing. Makes things a lot quicker with our machining time.
Okay, I found the article.
Okay.
I'm going to share it with you. So there you are, Eric. Okay, here it is. You should be able to have it on your screen right now.
Okay. There we go. High speed
Okay,
machining for milling.
so if you go down, this is a very good explanation of what high speed versus a standard cut is.
Mm-hmm.
In the left hand side, you see your normal offset packet. So
Mm-hmm.
what's happening in an offset packet? We're making rectangles, or we're offsetting the part, we're compensating to it until we get to the final shape. Now, what are the pros? It's got pros. The pros is easy to program. Just like this or zigzag, you could actually program it on your controller, or if you're very savvy with G code, you could actually do it yourself. Um, Shorter G code, so the code's smaller, easier to understand. Now, where the problem is first, we're working on straight lines.
Mm-hmm.
So if we're in a straight line and we get to a corner, there's gonna be an influx. So we either we have to be very conservative with our feed rate. And the
Mm-hmm.
second thing, if you go down in the article, you'll see that the load of the tool it's hitting the same area always. So you go a little bit higher to
Oh,
see the,
okay.
yeah,
This
that one.
one.
So
Yeah.
you can see that the tool, it's always cutting on the same area. So what's going to happen is if you're not using this and you're cutting harder materials, at the end of the day, you're going to take your tool out of your machine and you're going to notice that it's only cut in a specific area and you're losing the rest. Almost 70% of the tool is wasted. What's happening on the tricordial cutting, if we go down, you can see as we're doing these circular motions, the load of the tool it's distributed to every single area of the tool. So we're using all of the tool, not just 30 or 40% of the tool. We're using 100% of the tool.
Mhm.
So with this, what's going to happen is the tool will last longer. And because of the distribution of load, if you go lower, Eric,
Okay.
you'll see that go
Next one.
lower. Yeah, a little bit lower.
Okay.
You see that you will be able to cut deeper per pass. So we're not exaggerating here that using this with conjunction with feed rate control, which is something that Eric is going to show you in a minute, it's going like this is a reality. It's going to take parts that were hour and a half, 2 hours to 15 and 30 minutes. So if you're an older customer and you are already using this functionality with the feed rate control, good for you. You're probably making a good use of your product. But if you're an older customer, because there's features that have incrementally been added to the product to make this feature better. So this feature has been available in the system for a long time. Even B30s, customers with B30 have access to tricordial coding and high speed, but they didn't have access to feed rate control, or they didn't have access to keeping the tool down, or have access to better linking options. So this is a functionality that has been in our product for a long time, but we have incrementally making it better every single version. So even if you are using it today, you're probably missing out on a couple of good things that it had been added to it. So when we talk about feed rate control, is the ability of our software to understand how much material it's around the tool at any given point, and then it reduces our feed rate when there's a lot of material, and when there's less material, it just increases the feed rate. So that's what we're trying to show you guys, that upgrading and using this, it's a benefit to your shop overall. You may continue.
Absolutely. Traditional versus high speed. We also have a video on here. This is under bobcat.com and under the news articles, high speed machining for milling. Um, so that you can.
You can share the link on the chat.
Okay. Yeah, absolutely. There we go. So it's in the chat for you guys as well to be able to view the video of traditional versus high speed machining also. And this gets into the controlling the feed rates so that we can set a constant chip load and other settings like this so that we're not, as we're at this depth of cut here, we can make sure that we're using the same feed rate, using the same constant chip load. So each amount of material per tooth of the tool is going to be exactly the same. And we can go back to the software program here under adaptive roughing. When I scroll down to my advanced feed rates page, you can see this new user interface. It's not a huge difference, I wouldn't say, because it's the same workflow as in version 37 and older. It's just not a pop-out menu anymore. As we mentioned earlier, you can easily convert the toolpath in here and view the toolpath so that you don't have to back out of it, reopen every time. I think it's a little bit more useful to use here, but you can see down in this sort of feature tree here, we can go to the advanced feed rates. we see the adaptive feed rates here. That's what these settings are for here: radial chip thinning and adaptive feed rates. You can see the example right here. When we get into corners like this, there would be much more material for each tooth of the tool to be removed. So I can set a minimum feed rate and a maximum feed rate. If my feed rate here is set to, well, let's say the cutting feed rate is set to 100, when I go to my advanced feed rates and I have it set to 10%, it will go anywhere between 10 and 100 inches per minute into these corners to slow down into the corners and keep a constant chip load. And that can reduce chattering at the machine.
Yeah, if you can just compute the toolpath, generate
Sure.
the G code, and we can show then how the
Yeah.
G code will have the feed rate difference.
And we hit post this. As you mentioned, there'll be a lot more lines of G code, but a lot more efficient toolpath at the machine. You can see the feed rate starting at 44. That's the plunge feed rate. And then it's going down starting at about 10 inches per minute because we're doing a plunge, I believe, right? Well, we're
Mhm.
sort of spiraling around, but still it's got full tool engagement in the stock. So it's starting at 10 and then ramping up a little bit more from 15 to 20 up to 50 up to 100 inches per minute as it's going around, and I'll
The,
backplot.
the way the way I tend to describe this
Mm-hmm.
is the equivalent of having your operator feeling the vibrations on the machine. So sometimes when we want to get parts done quickly, we set up our operator, and if he feels that there's a lot of vibration or she feels there's a lot of vibration, we reduce. Then we feel that the cut's going smoothly, we increase, and this is happening in the code. So the machine will be doing these changes. And if you look at the code, it's happening gradually. So it's not like it's going to change from 10% to 110% like this. Not. It's just gradually going to change from one to another, taking care of your machine, taking care of your tooling, and eliminating that process. Now your operator doesn't have to be on top of your machine, feeling vibrations. They could be programming another part, setting up another machine, doing something else, which entirely differently that's going to help your shop be more efficient.
Mm-hmm. Great. So that was controlling the feed rate control through tricoidal milling. Um, Also, in terms of saving time with programming, we looked at templates, we looked at operation and tool manager.
Do you
Well,
have a part that has several features? Try to bring something like that that has like um, 10, 15 different features.
demo files. Oh, I might have something here. Nope. I would have that under. Let's see. Here's a few different ones on this one. There's three, four, five different features in here, and then flipping it over and doing the other side for the drilling and chamfering on this side as well. Um,
Okay, so this is an example, and I like to use real life examples. So you're programming this part.
mhm.
You've set up going to the country and then going to the operation manager where it says operations on the
So
button, and then change to the
the
tool
tool
tree.
tree right
Mhm.
here.
This is huge. Why? As you can see, our half-inch tool is being utilized for one, two, three, four, five, six, 7 different operations. You
Mhm.
see that? So we are using that half-inch tool, and that half-inch tool, for some reason in our shop, is no longer available. It broke. It wasn't there. So this is when the programmer and the operator have a disconnect. Like the programmer used these tools, and the operator's like, yeah, no, those tools are, I don't have that tool. Let's change it to this. At that point, the programmer has to, in prior versions of the product, and I think this is 35 below, okay, we'll have to go back to each one of these features, which are one, two, three, four, five, and change the tool on each one of them separately. So he will have to go find that feature, double click on it, just like Eric is doing right now, go into the tooling information, change the tool to whatever it needed to be, and then recompute. And he will have to do this process 5 times.
And try to find
Now,
each one and each feature.
exactly, and know which ones are the ones that have that. So with the operation manager, if you go to the operation and the tool, all you do is just right click on that tool.
Under the tool tree. Yep.
Yeah, just
Right
right
click
click
on
on
the
that
tool.
tool, edit the tool, change it to whatever size it needs to be. So we don't have a half inch. We're gonna be working with a quarter inch. I don't know.
Quarter inch. Yep.
Yeah. So press OK,
And then OK.
and then it's just gonna tell you all those toolpaths are no longer relevant because we changed tools. All you do is right click on the tool and recompute all.
Yep. Doesn't like one of them for a certain entry move with ramping
Yeah,
in.
that's probably a radius. The
Yep.
radius is probably smaller.
Yep.
But this saves you so much time because you don't have to be doing it one by one. And this is something I discovered. And me having conversations with different customers, they believe this makes a difference. It's important. Now, do you have a part where we're doing a matrix, like a toolpath matrix?
A toolpath matrix.
Mhm.
Like for toolpath matrix as in all milling operations?
Like
Or
if we wanted to take this toolpath do a sequence, that's a toolpath matrix.
oh, sort of like nesting? Or like a
Yeah,
toolpath pattern?
yeah, pattern.
Pattern. Gotcha. I don't have that necessarily, but it's very easy to make a shape in here that I want. We'll just go to our. I've done this many, many times in our shape library. Just create a star down at this corner here, bottom left, and I want to fill up the sheet of
Can you do no do
no.
don't do start do a use the shape library and
Okay.
create something that has internal geometry.
Okay. Yeah, good idea.
Yeah,
So we'll go to shape library. We'll do this one here with a
no,
sort of a
let's do one with a couple of holes so we have several features. So let's
this
do
one here.
that one. Yeah.
Okay.
Hmm.
And let's
Yeah, just
uh,
as it is. It's just for the sake of.
okay. And then bottom left, and I'll
Mhm,
shift it over a little. What I normally do is I'll shift it over like an eighth of an inch so that we're not right along the side of the sheet of material that we're cutting.
mhm.
So we have both options in terms of CAD. We could go to utilities, translate, and we could translate the part over and make multiple copies. Or
Mhm.
if I just want the one shape, I can leave it here and we can do it in the CAM side of it. So we go to
Which is
CAM.
going to be better because if we make one change, it changes everything instead of changing one by one.
Right, right.
Mhm.
So when I go in, uh, just make it quarter inch material, 4 foot by 8 foot sheet. I can right click on machine setup one. We go to mill two axis, select my geometry, click OK. We're cutting to a total depth of a quarter of an inch. We go and we can do a what
Just
just
a
a profile
finish.
finish. Okay.
Yeah.
And we have options for tabs. We have all of these other settings. Setting up our tool. We'll do eighth inch tool. It's pretty small
Hmm.
there. And then we also have, let's
Like
see,
offset to the right.
Offset to the
So
right. Still just doing the inside and outside.
you know what you need to do? You need to change the direction of the internal ones when you do the geometry selection.
Yes.
So
I
make
think
sure
it
you
was.
put it to the right, and
Yeah.
then just make sure that you pick it, and then do you see the chains on the left, on the
Mm.
bottom chains there?
Chains.
Make sure that the direction of the inner is counter counter to
There.
the outer. Exactly.
This one there. Yep.
hmm Now set up your offset to the right. Now it's no. Go to parameters and make sure that
Sorry. Let's just flip this one and this one,
yeah,
and then we can go to patterns and parameters and change
and
the
right.
compensation to the right.
That's perfect. Yeah. Now this is the part where I'm telling you, you're seeing what's happening on the spot.
Mhm. Right.
In
Yeah,
real
you
time.
can easily. Yeah, in real time, don't have to reopen the feature every time to compute it
Uh
and
huh.
see the results. And then when we compute, we can see the toolpath. We can make copies by right clicking on the feature and going to add toolpath pattern.
hmm
We can make I usually go to translate so that way I can move it however I want and make additional copies. I'll do 6 additional
No,
copies.
go back to no. Let's not make it translate. Let's make it. Let's
Do array.
make array.
Okay.
That way we can move from both axes.
Yeah. So 6 copies in, let's say, 8 inches in the x direction, 6 inches in the y direction, 6 copies that way as well.
hmm
And then we see the toolpath in green as
Can you change the color probably of the toolpath because
as a
it has
toolpath. I can just right click on the profile and color, and let's
and
change
make
it
it.
to something that we can see better here.
Mhm.
Like
And maybe you can get rid of the stock.
the stock. Yeah, yeah, we can
Mhm.
do that
That
as
should
well.
help as well.
Let's do a darker green, and then we'll blink out the stock so that we can see it.
Okay. So now the problem or the limitation to the toolpath pattern that we had before is being able to control what are we going to cut first and what we're going to cut last because the toolpath pattern in prior versions before like 35 it will just go in the order. You had no control.
Mhm.
But now when you go to your operation manager,
Operation manager.
each one of the profiles, it's a feature, it's an operation. So as you click on the operations, you're gonna see which one you're touching. Actually, yeah, that's it. If you want that one to be cut first, because the sheet might get hot and you want to be able to move from different positions, especially when you're doing plasma laser water jet. Here, using this, you can drag and drop and move it up to a different position. So that's being programmed in a different order than what you normally have. And you can do that to separately for the inner profiles or the outer profiles.
Hmm.
And when I saw this, I thought this was very, very important for customers to understand.
Yeah, definitely. Then we go back to the cam tree. The only thing I have left with our list here was not having to create wireframe for the lathe anymore, selecting
Oh yeah, yeah, you can.
surfaces, solids. So if we go into the lathe functionality, we'll go here, desktop, and lathe. So if I have a solid model like this, I don't need to make the wireframe anymore. I can easily go into a new job, turning, creating the stock from here. And then when I right click on machine setup one and I go to lathe turning to turn the OD, I can easily just select the surfaces here, solid and surface, and select each of the surfaces to turn down
There's an option to select the the full solid.
the full solid. So if I
Yeah, there
use
is.
geometry, I can
Uh-huh.
select solid body and select the solid as well.
And then you can see the chain.
Yep. Yeah. And then I can click OK. And then I can see the toolpath that it creates and keep going from there, creating, selecting that it's turning the OD, that I'm doing a roughing and a finish operation, selecting my tool. What I also like to show, this is a newer feature in the turning modules, is our chip break option. So if we look at it from a top view, if I turn off chip break, you can see it'll go all the way across the stock. There will be a lot of built up material as the tool goes across here. I can turn on chip break and it will go across, retract at this location, go across, retract. I can set a retract distance and the length of the cut before it retracts out of the stock so that the material isn't built up on the tool as much. So if I change it to 1, it'll run across 1 inch. And I can, as you mentioned, I can backplot this and see it retract, go across, retract, so that it doesn't run all the way across the part and have a bunch of built up material along the tool to mark up the
Yeah.
stock.
The fact that we can see it, for me, that has been huge.
Yeah,
Because,
definitely.
yeah, like you now, like if you change the length or if you change the distance between the tool breaks, you can see that happening as you make the changes. So again, that's always going to be very helpful.
Right.
Now, I just sent you a link
Okay.
for something that I want you guys to do, and it's something that we created for customers. And basically, we actually tested it with one of our beta testers, and it looks like it makes sense. So that if we go down,
Mm-hmm.
it's an exercise that you guys can do with the system, and is how many machines you have, um, how many hours are your machines working for, how much you charge for hour rate, and what version of the product are you breaking tools, and how often are you breaking tools? So what's the average price of your tooling? That's 180. Do you have scrap incidents where you just have to get rid of material because of tolerance difference or something? So basically, you enter all your shop information here. You press next.
Okay.
You define what functionality you're adding to the system. In this case, feed rate control. We're using adaptive collision. When we press next, it's gonna give you an estimate of how much is the software is going to save you coming from that version. Now you can actually and then how much is your upgrade and how much is your maintenance going to be. If you go if you don't believe the tool breaks is important for you, let's say you're getting 0 breaks, so go to breakage and you can move that to 0. Like in the experiment that we were talking to Lars, he said, for me, tool breaking is part of the job. I like to break tools to move my tool to the maximum, so I don't care for that. So we remove that factor. You know, okay.
Mm-hmm.
Um, just like tool life improvement, so we can set that on 0 as well on the top.
Okay.
Yeah. But then he said from B24 to 38, because he's been working with 38, he felt like the programming time
Mm-hmm.
has been reduced exponentially. So we made that programming reduction from 25, we made it 15%.
Programming time reduction.
Uh-huh. We made it
Okay.
15%. That's what he
Mhm.
believed was the impact. On cycle time, he does believe 12% to be around where it needs to be. And then after entering all this information, you press next, and the system's gonna tell you like how much money are you gonna be able to make out of these changes. Now, again, we're gonna be able to get there with the training, using these features, making sure that you are reducing your time, making sure that you're probably using premium toolpath instead of pro toolpath, so you don't have to be polishing or scrapping material. So all this changes can happen to a shop. And we've done it with two different customers that they do say that Bobcat has such an impact on their shop, with on savings specifically. So I want customers to just go check it out. If you can, yeah, you put it on the chat.
Yep,
Thank you.
I put it on the chat.
Uh,
No problem.
Go check it out. Take a look at it. It's something that it's worth trying. And if you are not sure, if you maybe think like, yeah, this is not, I don't think this is gonna happen for me, send us a part. Eric, you can do a demo. I can do a demo, and we can show you how these new features and new functionality are going to save you the time and the money on your shop. Okay, perfect. I think we had a very, very good webinar.
That was great. Were there any other topics we wanted to cover today, Tatiana?
Maybe you can show a little bit about the premium toolpath and why are they different from Pro.
Okay,
Just a quick explanation.
absolutely. So this is normally my demo file I will show um, for the three-axis premium toolpaths, the difference between Pro and Premium, with a sort of an odd shape like this, not something with natural features, right? We go to our milling job, we set up our stock, and we set up our machine setup on top of the stock. It's all the same workflow as in the 3-axis Pro. I even have a 3-axis Pro roughing operation, and then we get into the 3-axis premium tool paths for our finish operations. And that would be when I right click on machine setup 1, they're going to be found under mill 3 axis right below that, mill multi axis, and uh, so that this is for 4 and 5 axis machining as well, but also for 3-axis premium, where we offer deburring for 3-axis. So if we're using a ball end mill or a chamfer tool, we have a deburring feature to be able to break edges. We have our surface-based toolpaths as well for all of our 3-axis premium toolpaths. Parallel cuts you can see here going across or down surfaces. The first one that I normally show is this one here, cuts along curve, where we're focusing on the top surfaces here and selecting the direction of the cut. And it will create toolpath exactly on the surfaces that I select. These are the 3-axis premium toolpaths are our surface-based toolpaths. So I'm selecting my tool first, just a 3/8 ball end mill. I'm selecting my lead curve, which will be the toolpath direction. So the toolpath is going to go perpendicular to this lead curve that I select, and then the drive surfaces as well will be the toolpath will be driven from these surfaces that I select. And again, the lead curve going perpendicular to that direction. One way, zigzag or spiral around the surfaces. I'm usually doing zigzag. And one of the biggest features that I like in the premium toolpaths as well will be the maximum step over. So we can either calculate the step over just by typing it in here manually, or we can calculate it based on the desired cusp height, or some customers will call it scallop height. So if I want to go, let's say, half a thou here, you can see that the maximum step over calculates based on half a thou cusp height, no more than that. So instead of having to go into simulation, make sure everything is cut to size, and seeing that there's still material remaining that I want to remove and go back in, change the step over again, I can just type in that desired cusp height and it will calculate the step over for me automatically here. We go into 3-axis machining for our tool axis control. Next page is a Gauss check page, just like in the Pro toolpaths. Our linking for each step over, just a direct
Here
step over.
on the linking is huge because you have a lot of
Yes.
control.
Yes.
What's going to happen is if you have a gap, or if you're moving from one operation to another, you now can tell the system what to do. Like
Right.
and this is something that it's applied to B36 Pro. Pro toolpaths now have the ability to have this linking page, which is an advanced linking page that gives you a lot more control. So we should do a webinar only just on this advanced interface because it's so helpful. But just
Definitely.
wanted to point that out.
Yeah, definitely. There's a lot of settings like this. The linking for each step over, the roughing. If we're going down into a channel like this, we could also set a number of roughing passes, how far they're going to be spaced out, number of finish passes, and how far they're going to be spaced out. So a lot of ways to be able to
Something else
optimize the
that
toolpath.
this premium toolpaths have that we don't have on the Pro is being able to mirror the toolpath. Go back to that part.
Yeah, so that was under
Yeah,
roughing and mirror.
mirror. And that's huge because generating a symmetry of a toolpath is very important. If you're
Yep.
trying to do this with the Mill Pro, what you have to do is you have to take your solid, do a mirror on the CAD,
Mhm,
reselect your geometry, reset up your boundaries, recompute the toolpath, and then you have the mirror. So the difference here is that once you're done with the toolpath, if you need a symmetry of that toolpath, if you need to mirror it, all you do here is click the find a symmetry point or a line, and the
mhm,
system will just regenerate your toolpath with the symmetry. And that's something that you don't have with the Pro toolpaths.
mhm. Right. And then we'll hit OK and then compute the toolpath. And that's how the toolpath looks here. One other setting that I really like in the premium as well would be under parameters, the extend and trim toolpath as well. So you can see with this toolpath, it's just ending right along the edges here. And if I want to go a little bit further past these radiuses, I can go to my extend option. And here's our tangential extensions. I can go past an extra eighth of an inch, we'll say, on both sides. Hit compute, and then we can see the toolpath extend a little bit further past in that direction there. So it'll go past the radiuses and go across.
This
The
part, this part on the last INTS, Eric,
mm-hmm,
we had a customer who wanted to program cut along that specific fillet between the
mm-hmm,
two solids.
mm-hmm.
That's nearly impossible to do with the Pro because it's just not going to follow that fillet specifically. That fillet, do you see it under
Uh,
just under your toolpath?
yes. So these here.
That, So if you were trying to do those with the Pro, that will be very difficult. But if you
Yes.
actually use between two
Yep.
pass
So that's
between two curves,
the next one down here. Right after cut along curve, we have morph between two curves.
and that should generate that toolpath. And that's something that we were not able to do it with the Pro.
Right. Because our geometry selection, drive surfaces, we'll just select all of the fillets all the way around here.
Hmm.
Doesn't necessarily matter the order of how I select them, which I like. Just select each of those. Then our first edge curves would be everything on top, all of these edges of the surfaces here. Go around, let's see this one and this one. And then our second edge curves would be all of the edges down at the bottom of each of the surfaces. And what it will do is calculate the tool path to start on the first edge curves that I select and morph the tool path from the first pass to the last pass, which are the second edge curves right here. And so we'll just type in our step over. Let's
Set it
go
up to 3 axis.
20 thousandths and also set it to 3 axis on my next page
Hmm.
and then hit compute. And so you can see it creates the tool path. You can see it morphs the tool path a little bit larger step over in these areas. Then we get into the corners and a smaller tool path to have the same deviation, same kind of cusp height all the way along the part.
Yeah.
And we can back
So
off it.
this is where premium is going to make a difference. Also, you have the ability to use borrow tools, which
Mm-hmm.
are going to make your programming faster, your machining faster.
Mm-hmm.
So again, there's a lot of reasons. We could spend 2 hours here talking about the reasons why people should upgrade. Hopefully, what we covered today was helpful. And well, just please let us know. We're gonna send you a survey like we normally do to know what do you want to learn next. I thought this topic was selected by me because I wanted to go over specifically now that 38 is out, some of the reasons we should be upgrading, we should be on the new version, and how it's going to help you ultimately help you save time and money. So thank you so much for your time. Thank you, Eric, for doing this with me.
Yeah.
Well, we'll see you on the Wednesday, the 12th. Oh my God, 12th of November. So we're almost done with the year. um, Anything you guys need, just like Eric did, he's gave you your tech support phone number, or write to support@bobcat.com, or write to me directly if you have questions about what you saw today. Don't I try to answer all the the emails I get. So thank you so much for your time. Thank you, Eric, and well, see you on the next one.
Thank you, Tatiana. Thank you, everybody. Have a great day.
You too.